Hello everybody, getting ready to do lesson 7.7, part 1, pre-calculus math today, classwork. Here's my email, animatedpowerpointmathvideo at AOL.com for course materials. And today's classwork, we got 18 points here for notebook. It goes into your notebook. And then 36 points here on your classwork sheet. Have those ready to go. And name, date, students, put it there. If you're in my classroom, go period there. And today's bell work, students, teachers, factor these expressions here, factor both these expressions, give you 5 minutes, see you in 5. Okay, everybody, welcome back for your solutions to today's bell work, 4y squared minus 12y plus 9. Your solution up here will be 2y minus 3 squared for your factoring there. And then down here will be 2y minus 7 squared. So this should be a kind of a giveaway here. That's a giveaway, and then your A member is a square, perfect square too. So that's your factoring. Into our lesson today, into your notebook here, the determinant of a 2x2 matrix. Every square matrix can be associated with a real number called its determinant. Determinants have many uses, and several will be discussed in this and the next section. Historically, the use of determinants arose from special number patterns that occur when systems of linear equations are solved. For instance, the system here has a solution. Okay, so for this expression here, x equals c1b2 minus c2b1 over a1b2 minus a2b1, and y equals a1c2 minus a2c1 over a1b2 minus a2b1, provided that a1b2 minus a2b1 does not equal 0. Note that each fraction has the same denominator, so these are same here, that's same there. This denominator is called the determinant of the coefficient matrix of the system. Coefficient matrix and determinant. So here is a matrix here, then here would be your determinant. Determinant of A would be A1B2 minus A2B1. So A1B2 minus A2B1. So you have almost like a cross multiplying thing going on. The determinant of matrix A can also be denoted by the vertical bars on both sides of the matrix as indicated in the following definition. Definition of the determinant of a 2x2 matrix. The determinant of the matrix A here in this situation here is given by determinant A equals absolute value of A, or absolute value here of a1b2 a2b1, and it equals a1b2 minus a2b1 would be the situation here about how you would figure what your determinant is of a matrix. In this text, determinant A and absolute value A are used interchangeably, so this is just an A inside 2 bars. Are used interchangeably to represent the determinant of A, although vertical bars are also used to denote the absolute value of a real number. The context will show which use is intended. A convenient method for remembering the formula for the determinant of a 2x2 matrix is shown in the following diagram. So here is your diagram here, determinant A, multiply that way and multiply that way. And then that provides your difference, your subtraction over here. So A1B2 will be your first term here, and then A2B1 will be your second term there. Note that the determinant is the difference of the products of the two diagonals of the matrix. Yeah, we see that. So let's go into our first example here. The determinant of a 2x2 matrix, find the determinant of each matrix. So here's the matrix here. What's the determinant of A? So the determinant of A will be when we multiply like this and multiply like that. We get 2 times 2 minus 1 minus negative 3. would be 4 plus c, so it would be 7. So the determinant of this matrix will be 7. And then for b, 2, 1, 4, 2. So that determinant would be 2 times 2 minus 4 times 1 would be 0. So you'd have a 0 determinant here for b. And then for c, there's our matrix, and then our determinant for c, be 0 times 4 minus 2 times 3 over 2. Be 0 minus 3, be a negative 3 for that situation there. So let's try one now. Find the determinant of this matrix here. I'm going to let you do this on your own, students, but we'll do this one now. Guided practice. So that one here is your determinant. Here will be 6 times 3 minus 2 times negative 5. 6 times 3 and then minus negative 5 times 2 would be 18 plus 10 be 28. Do I do that one? I don't want to. I want you to do that on your own, students. Go back into the video if you want to see it on your own. Notice in example 1 that the determinant of a matrix can be positive, 0, or negative. The determinant of a matrix of dimension 1 by 1 is defined simply as the entry of the matrix. For instance, if A equals negative 2, then the determinant would be negative 2. Okay, so going into our page 9 here, it goes in your notebook. Most graphing calculators can evaluate the determinant of a matrix. For instance, you can evaluate the determinant of matrix A in example 1A by entering the matrix just as A there, matrix A, which is a 2 by 2, and then this is like outlined here because it's in see, row 1, column 1 would be 2 for that situation there. So, and then choosing the determinant feature, the result should be 7, as in example 1A. So determinant A would equal 7. That would be a screenshot for your calculators. Page 10, minors and cofactors. To define a determinant of a square matrix of dimension 3 by 3 or higher, it is helpful to introduce the concept of minors and cofactors. Minors and cofactors of a square matrix. If A is a square matrix, then the minor Mij of the entry Aij is the determinant of the matrix obtained by deleting the ith row and the jth row of A. The cofactor Cij of the entry Aij is given by Cij, here's our cofactor, equals negative 1 to the I plus j power Mij. So, wow, what's that? In the sign patterns for cofactors at the right, notice that the odd positions where I plus j is odd have negative signs, and even positions where I plus j is even have positive signs. So, where is that? This chart will come up here. Just hold on for a second. Sign patterns for cofactors. Here's your 3 by 3. So in the sign pattern here for cofactors, notice that the opposition where I plus j is odd have negative signs. So here is your negative here, row 1, column 2. This would be row 1, column 1. And then even positions where I plus j is even. So this would be row 1 and then column 3 here. That'd be even, odd. Then this would be row 2, column 1. This would be odd, etc. So that'd be how you would figure your signs of your cofactors. And then this would be even a bigger. This would be an n times n matrix here. So it just continues on with that pattern. Okay, let's try one. Example 2, finding the minors and cofactors of a matrix. Find all the minors and cofactors of this matrix here. So to find a minor of minor 1, 1, delete the first row and the first column of A. So we delete this, delete that, and evaluate the determinant of the resulting matrix. So this would be your matrix here, like that. So you have negative 1, 2, and then 0, 1. So now we figured the determinant of that. So finding the minor of this position here. I mean, when you do that, then you come up with -1 times 1 minus 0 times 2, you get -1. So when you delete your first column here and your first row, you get this here. Then you figure the determinant of that. Similarly, to find the minor M12, delete the first row and the second column. So this would be the format here to find M12. To find your minor here of this position here, you would end up with 3, 4, and then 2, 1. And that one, for that position, to find your minor, you would have this matrix here. So you have 3 times 1 minus 4 times 2 equals -5. Then continuing this pattern, you obtain all the minors. So here be all the minors for these different positions here. Once you continue on that kind of pattern of discovering minors, for M33 would equal -6. So 3, 3 here. So let's try one. Let's show how this is done. Continuing this pattern, you obtain all the minors. So here are all your minors here. And now to find the cofactors, combine these minors with a checkerboard pattern of signs. For a 3 by 3 matrix, here is your sign shown here. And then here's your cofactors here. So here's your signs here. Here is your sign chart, and then here's your minors here. So your cofactors would be you're finding your minors and then changing your signs accordingly. So here would be negative times -5 would be +5, and then +4, then 2. Here would be a -2 now, because you have to add your sign chart into that number there. And then over here, -4. This just stays the same, and then over here 8 will become -8, and then etc. 5 will stay the same, 3 will become -3, and then -6 will stay -6. Okay, so let's try one here now in exercise 15. Find all minors and cofactors of the matrix. So here's our matrix here. Here's the sign chart that we would use for a 3 by 3. So to find our M11 here, and then M12, M13, which would be down here. So for M11, we would it would also close that off up here. So you would have this situation here. For M11, you would have -2 times -5, and then 0, 8. And then that would equal a 10. And then for M12, which would be this position here, M12, you have 7, 8, 1, -5. Then so you have 7 times -5 would be -35. And then 1 times 8 would be 8. How does that figure? Wait a minute. -5 and then 8. Huh. And then for here, for M21, so M21 now will be 6, 3, and then 0, 5, so it'll be -30 and then 0. And then for M22, it would be -4 times -5, that'd be +20, and then 3, -4, -5 be +20, and then 3, this should be 23. I don't know how they're getting these numbers. These are incorrect. And then for M23, we have -4 and 6, and then 1 and 0. So this would be -4 times 0 would be 0, and then 1 times 6 would be -6 here. I don't know how they're getting -6. This 1 times 6. Oh, because it's minus. So that's my bad. Okay, so you subtract here. Okay, then through your M3 1, so it'll be M3 row 3 1 here. I'm going to let you do that. So now when we have these numbers, we find C11, and then we change the sign of these. We get 10, 43, and 2, and then 30, 17, and 6, then 54, 53, and negative 34. So that would be our solutions there for those. And then that is your 7.7 Part 1, Pre-Calculus Math, Animated PowerPoint Math video. Email me for materials, class worksheets, homework sheets, solution PowerPoints, anything else. Thank you.